Google claimed that it had achieved quantum supremacy. In October of that year, Google released the paper stating that it had achieved quantum supremacy with its quantum computer, which had run calculations for a task in 200 seconds, and that the same task would take the most powerful supercomputers at least 10,000 years to solve. IBM, the New York multinational technology giant, refuted these claims almost immediately, claiming that they could solve the problem with their supercomputer in just 2.5 days. Now, you've got to wonder, why is this statement from Google so important that IBM seems to not want it to be true? What is quantum supremacy, and what is quantum computing? Also, why is the Chinese government heavily investing hundreds of millions into the same project? Welcome back to our channel. If you haven't already, make sure you hit the subscribe button and ring that bell so you're notified every time we upload a new video. Alright, so it may sound weird to talk about Google beating innovation in a surprised manner. I mean, we should expect these kinds of landmark achievements from them every once in a while, right? They did, after all, create the most efficient information tool with their search engine that generates hundreds of millions of answers to your questions in half a second. And although you'll only visit the second page when working on a school project, Google's search engine is so good that it will search you as well. They also created the Google Recorder app in 2019 that makes transcribing, recording, editing, and even translation seem like child's play, as the app was voted the best app. And the Recorder app is so good that some people even claim that it doesn't stop working even when you shut it off. But no, quantum supremacy is eons beyond these innovations in terms of possible impacts. So this brings us back to what is quantum supremacy. And quite simply, it is when a task is run on and solved quickly by a quantum computer. A task that is so hard, a classic computer would not be able to solve it. In this case, Google made use of its own quantum computer built from scratch, Sycamore, to achieve quantum supremacy. Sycamore is part of the company's quest to develop a useful, error-corrected computer by the end of the decade. And to help meet this goal, Google has built a quantum AI campus in Santa Barbara with hardware research labs, a data center, and facilities for developing quantum processor chips. By the end of the decade, Google would have spent billions to perfect quantum computing. But what really is quantum computing? To understand quantum computing, we'll need to make use of some simple concepts from quantum mechanics. And to do that, we'll need to start at the very beginning. For over a century, physicists have tried to understand the physical properties of objects at the subatomic level, also known as quantum mechanics. Some of the greatest minds like Einstein, Heisenberg, and Niels Bohr have tried their hands at it. Because quantum mechanics was hard to understand and seemingly irrational, Erwin Schrödinger kind of made a popular quantum mechanics for dummies thought experiment that is now known as Schrdingers Cat.
We might consider Schrodinger's cat.
This experiment consisted of a closed steel container, a cat, and a radioactive poison that will detonate randomly. Now, because we do not know whether the poison has detonated, we can think of the cat as being both alive and dead until we actually open the box to observe it. This attribute of being in two different states at once until measured is called superposition, and it's a characteristic feature of subatomic particles like electrons and photons. Now, while classic computers mimic humans in the way that we carry out calculations using bits of ones and zeros as data, quantum computers like Sycamore mimic nature using quantum bits or qubits of both 1 and 0 as data. These qubits can exist in both states of data at once and change accordingly to give the required answer for a task. And this also means that compared to bits, qubits process a ridiculous amount of information faster. And this ability to process more information faster increases as you increase both the bits of a classical computer and qubits of a quantum computer like Google's Sycamore. For instance, unlike 2 classical bits that will exist in either of the 4 states, 2 qubits can exist in all 4 states at once, 3 qubits in 8 states, 4 in 16, and so on. The qubits in the circuit are entangled in such a way that this helps the computer affect the changes across all the qubits to arrive at the correct state that generates the solution to your task. This behavior is also derived from quantum mechanics and was described by Einstein as spukhaft Fernwirken, or spooky action at a distance. This is the effect where 2 particles are correlated with each other in such a way that you can actually predict the properties and behavior of any one of the particles just using one of them, no matter how far apart they are from each other. Google's current quantum computers have less than 100 qubits, and a quantum computer with 300 qubits would have more states than we currently have atoms in the observable universe. However, the company has set a goal of creating a computer with 1,000,000 qubits. That's a goal that requires a lot of patience and hard work, which the brilliant team at Google and Quantum AI are ready to undertake. The reason why building quantum computers has been an issue is because qubits are not stable and need special conditions to work. Google's quantum computers, like this steampunk-like chandelier, has something called the Josephson junction that converts the bits to qubits. Meanwhile, the build of the computer ensures that the electrical and magnetic interference are avoided, while superconducting is also achieved by using the cryostat to bring the temperature close to absolute zero. All this delicate care is necessary because the possible monetary gains, as well as social advancements, are quite simply immense and maybe even unknown. So we've understood some concepts of quantum mechanics and quantum computing. Or maybe we haven't. Maybe it's both, where you can't really explain it, but you kind of get it. Well, I hate to break it to you, but your brain has just been superimposed. And it has massive implications if fully implemented. I mean, we'll be solving problems with the power of nature and the universe. And because quantum mechanics is actually not fully understood by anybody, including scientists, these quantum computers can help us have a better understanding of quantum mechanics itself as more progress is made. Google's quantum computers will have real-world applications. For instance, it would be able to correctly predict the best combination of molecules for drugs, which is today done by scientists in a sort of trial and error method. This would save a lot of time, as well as cut off a whole lot of cost and waste. And speaking of predictions, it can also be useful in creating models for projects and theories, as well as making financial forecasts. They can also be used in the implementation of even safer encryption technology than any we currently have. Quantum computers would make cryptographic functions for blockchains look like a joke. But on the flip side, they can easily hack private keys as well as other security systems using weaker technology. So I guess we know why the Chinese government wants to get there first. However, the presence of a quantum computer does not mean that classical computers will cease to exist, since they are fundamentally different with respect to the computational processes that they mimic. Quantum computers are just here to solve the really data-heavy tasks that would otherwise be impossible even on the most powerful